Hi everyone, welcome back to Lulumath. This video is another transformations of functions problem, and this video is going to go through an absolute value example. And you'll need to know all the different transformations a function can go through, and there's a video on it called Transformations of Functions Part 5 at lulumath.com or the Lulumath YouTube channel, and it goes into detail about what these different transformations are. We're going to just do a quick description of the transformations, but if you want a better understanding, make sure you check that video out. So just a reminder that this is the general equation of a transformed function. And the a value will tell us whether we have a vertical stretch or compression and whether we have a vertical reflection or a reflection in the x-axis. The f here tells us our function rule. So is it an absolute value function? Is it a square root function? Is it a quadratic function? The k value will tell us our horizontal stretch or compression, as well as whether or not there's a horizontal reflection or a reflection in the y-axis. The d value will tell us our horizontal translation, and the c value will tell us the vertical translation. And a really important note that you cannot forget is that this k is k multiplied by the quantity x minus d, which means that k must be factored out. Otherwise, the d value will be inaccurate. All right, let's go ahead and apply the information. So we're going to consider the function given to us right here. Okay, let's get right into it. So we want to consider the function that's given here. And we want to determine the parent function as well as describe the transformations done to the parent function to result in h of x. And then we're going to graph that function. So for starters, please do not forget to factor out the k value, if necessary. So this right here, because it's not 1/4 multiplied by an entire quantity, we know that we have to factor out a k value. So we're going to factor out a fourth. And when I factor out a fourth from 1/4 x, I have an x left over. But when I factor out a fourth from -1, remember when we factor, we divide. So I'm going to take -1 and I'm going to divide it by 1/4, or my k value. But remember, when we divide, we actually are going to multiply by the reciprocal. And the reciprocal of 1/4 is 4/1, or just simply 4. So -1 times 4 is -4. So this should say 1/4 x minus 4 right here. Because that value will tell us the d value, I'm going to write this in green so we can see what's going on here. And then this is the absolute value of all of this stuff because that is our function rule. Let's double check to make sure we factored this correctly. So 1/4 multiplied by x gives us this 1/4 x, and 1/4 multiplied by -4 gives us this -1. So we did do it correctly. Awesome. A common mistake, however, is that people will accidentally take out the 1/4, say that 1/4 x divided by 1/4 is x, which does work, and then accidentally multiply this -1 by 1/4. So they'll say it should be x minus 1/4. But when I distribute this through, 1/4 times x is 1/4 x, and then 1/4 times -1/4 is -1/16, which is not what we are looking for. So this does not work. So be careful of that. Now this -2 here represents the a value, so I'm going to put -2 in red, and this -6 represents the c value, so I'm going to put -6 in orange, and then I'll just copy down h of x. And now we're going to use these values to determine what the transformations that have been done to the parent function, which is the absolute value of x. So we know that our a value is -2, and this tells us two pieces of information. The first thing it tells us is that we have a vertical stretch with a scale factor of 2, but because it is negative, it also tells us that we have a vertical reflection. Now the k value is equal to 1/4. And don't forget that whenever we find the k value, we have to do the reciprocal of it to find the scale factor. So our scale factor is the reciprocal of 1/4, which is 4/1, or just 4. And that tells us that we have a horizontal stretch with a scale factor of 4. Now the d value is equal to +4 because this minus sign, remember it's x minus d. So because this minus sign is preserved, it tells us that the d value is a +4. And this tells us that the graph has been translated horizontally 4 units to the right. Lastly, this -6 tells us what the c value is. And that tells us that we have a vertical translation 6 units down. So now that we've done that and we have also identified our parent function, we can use this information to figure out what our coordinates are going to be for our graph. So for our parent function, since it's the absolute value of x, we will go from -3 to +3 for our inputs. And the absolute value of all these values are its positive corresponding value. So the absolute value of -3 is +3. Absolute value of -2 is +2. And then I'll just continue with the chart. And the first thing we do is our dilations. And our dilations come from the A value and the K value because these values tell us our stretches or our compressions. So since we have an A value of -2, we are going to multiply all the Y values by -2. And since we have a K value of 1/4, that tells us that we have a scale factor of 4, so we're going to multiply all of our X values by 4. So in our new chart, we'll have 4X and -2Y. So when I multiply all of these X values by 4, I get -12, -8, and I'll just keep going. And when I multiply all of these Y values by -2, I end up getting -6, -4, so on and so forth. And now that I've done that, I can do all of my translations. And my translations come from the D value as well as the C value. So the D value tells us that we are going to add 4 to X. And the C value is going to tell us that we are going to subtract 6 from Y. But this is going to happen to this table of values here. So that means we are going to take the 4x and we're going to add 4 to that. So I'm going to take all of these x values here and add 4 to them. So -12 plus 4 is -8. -8 plus 4 is -4. -4 plus 4 is 0, so on and so forth. And then I'm going to subtract 6 from these y values. So I can write down in my heading here -2y, and then I'll write -6. So when I take -6 and I subtract 6 from it, I end up getting -12. -4 minus 6 is -10. -2 minus 6 is -8. 0 minus 6 is -6, so on and so forth. And this table of values right here represents what h of x is. Now, just a reminder that your xy can go straight to 1 over k times x. This will do our horizontal stretch or compression as well as a reflection if there is a reflection, plus d, which represents the horizontal translation, just like we did the 1 over kx right here, and then we did the plus d right here. And then we can do a times y, which is what we did here, and then add c to it, which is what we did here. So if you look at this chart right here that we're looking at here, our final graph is this summarized piece right here. So if you want to skip straight to that, you are more than welcome to. I like to do it in pieces because I want to make sure that I understand what I'm doing and why I'm doing what I'm doing. But if this makes sense to you, you can go straight to this. All right, let's go ahead and set up our graph, including numbering and labeling our axes. So on my x-axis, I've gone by 2s, and on my y-axis, I've gone by 1s, but I've only labeled every other line in my graph. And I'm going to go ahead and graph out my points. And this graph represents this function right here. Last thing I want to talk about is the domain and the range. So the domain, because it's an absolute value graph, you can plug in any value of x into this equation here, and you will always get an output. There is no restriction. My graph goes in both directions without any issues. So I can say for my domain that x is an element of the reals, or I could just simply say it goes from -infinity to +infinity. But for my range, however, my graph reaches a maximum point. And just by looking at this equation right here, I know that information without even looking at the graph, because I know that my vertex is going to occur at 4, -6. And I also know that it opens down because of this negative value here. We have a reflection. So we know that it's going to reach its maximum point at -6. So this tells us that our range has to be y is an element of the reals such that y is less than or equal to this maximum point it reaches here, which is -6. Or we could say that it is from -infinity to -6 where -6 is included, but negative infinity is not because we can never reach negative infinity. And that's it for this video. If you have any questions, please let us know in the comments below or at lulumath.com, where you can find blank or completed notes for this video. If you found this video to be helpful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.